Hello students, welcome back to my second lecture of the chapter, that is motion. Yesterday we people discussed about rest and motion, and the most important was the frame of reference. Today we shall be discussing two important basic terms used in motion, that is distance and displacement. So before starting distance and displacement, be ready with your notebooks and pen because you people will be required to note down few important things. So after studying the concept of motion, the first question comes in our mind is how much motion, means how much an object has moved from one position to another. Means there is a need to quantify that concept of motion. This was the first thing which came in the mind of Galileo because he wanted to measure that how much far an object has moved from one position to another. So the name of the quantity that measures how much far an object has moved is known as length, or you can simply call it distance. There was a need for the scale to measure that length or distance. So in ancient time, what we used to do, we used to measure the distance by our palms, by our foot and by our hand. But it was very difficult to continue with these scales as everybody is having different sizes of their foot, hands and palm. There was a need for some unit, for some scale which is same throughout the world and is acceptable by everyone. So the standard unit, the SI unit of length and distance which came out was meter. Now let's take an example. Here we are having our school, and this is the building where we have three different flats, and all three different flats, three students are living, student A, student B and student C. For our convenience, we are taking school as our initial position, which is the north direction, like our school is in the north and whereas our building is in the south, and we are taking our building as the final position. So what is happening here? From the school, three students, student A, B and student C, they are going back to their homes, but they are taking three different paths. Student A first of all goes to an ice cream parlor, eats an ice cream and heads back to his building after covering 600 meter. Student B covers 300 meter, whereas student C is a bit kind of naughty. He first of all goes to his friend's house, enjoys chatting, and after that he goes to his home after covering 800 meter. We can clearly see that for the same initial and final position, three students have chosen different path, and for them their distance traveled is also different. So for all three students, the distance traveled is different. So what is distance? Distance is the actual path covered by an object. So distance traveled by student A is 600 meter, distance traveled by student B is 300 meter, and whereas distance traveled by C is 800 meter. And this all three distances, it depends on the path they are choosing. It totally depends on the object at what path they are choosing. Now, interesting thing to note is that although for the same initial and final position, distances are different, but there is a shortest distance between the initial and the final position, that is 200 meter. But for our convenience, we need to add direction in that because we should know that shortest distance in which direction. So for the same initial and final positions, the distance traveled by all three students, it is different, but the shortest path between the initial and final position is 200 meter in the south direction. So this is the displacement for all three students, which is the shortest path. So we can conclude that displacement is the shortest distance between the initial and the final position. It only depends on the initial and final position. It does not have any connection with the path chosen by the object. So here we are getting 2 points of differences between distance and displacement. Now Let's come to another example. We are having a small scale in which we are allowing a car to travel some distance. Let's suppose initially the car is at position A and it is moving in the negative direction. See here, this is our positive direction and this is the negative scale, it's a negative direction. So what is happening here? The car A travels some distance and reaches point B. So what is the distance traveled by the car from position A to position B? We can see that 1, 2, 3, 4 and 5. So total distance traveled by the car from position A to position B is 5. We can simply say 2 plus 3 is equals to 5. But what is the displacement? What is the shortest path between A and B position of the car? So to find out the displacement, you can simply use the formula final position minus initial position. What is the final position of the car? Final position of the car is B, which is minus 3. So you have written here minus 3. And what is the initial position? We will put a minus sign and initial position is A, that is 2 meters. So you have put 2 meter here. So minus 3 meter and minus 2 meter will give you minus 5 meter. Here what is 5 meter? 5 meter is the magnitude, whereas this negative sign shows the direction. It means that the car is traveling in the negative direction, in the left direction. So from here we can simply conclude that distance has only magnitude. It has only the numerical value, whereas the displacement is having both magnitude and direction. It has 5 as magnitude and minus sign as direction. We can take another situation in this example. Let's suppose after reaching position B, the car goes back to its initial position, means it returns to its initial position. So what is the distance traveled by the car? Initially it traveled 5 meter and again from B to A it traveled 5 meter. So 5 meter plus 5 meter will give you 10 meter. Now what is the displacement in this case? You can clearly see that car traveled from A to B and then from B to A. So its initial position is also A and its final position is also A. So both are same. So there is no difference between the initial and the final position. The displacement is 0 meter. So from here we can see that the displacement is always positive. It will always give you a positive numerical value, a number, whereas displacement, it can be positive, it can be negative, it can tell you the direction and it can also be 0. Let's take another example. Here we are having a circle. There are two positions, position A and position B. An object is traveling from position A to position B. So what is the distance traveled by the object from position A to position B, which will be the actual path covered? So it will be, we can clearly see it is a half of the circle. So half into circumference. Half, the circumference of the circle is 2 pi r, where r is the radius of the circle. 2 and 2 cancel, so you will get a distance traveled as pi r. What is the displacement of the object from A to B? We know that displacement always depends on the initial and final position and it is the shortest distance between them. So the shortest distance is AB. So what is AB? This is R and this is also R. So R plus R will give you 2R. So clearly we can see that distance is the actual path, whereas displacement is always the shortest distance between the initial and final position. Distance is depending on the path chosen by the object, whereas displacement will always be depending only on the initial and final position. Distance will always have the numerical value, whereas displacement will have both magnitude and direction. One more thing to add here, the quantities which are having only magnitude, only the numerical value, they are known as scalars in physics, whereas the quantities which are having both magnitude and direction, they are called as vector quantities. So Distance is a scalar quantity because it depends only on the magnitude, whereas displacement is called vector quantity because it is having magnitude also and direction also. Hope you people understood the concept of distance and displacement. If you like my video, you can subscribe to my channel. You can press the bell icon, and whenever I upload my video there, you will get the notification. Thank you. Have a nice day.